Hey friends, this is Nick and I call my channel DZ Performance, and I really appreciate you tuning in. The dyno testing that I've got to bring you this week is I ran my 454 HO motor with casting number 236 peanut ports. The 236 peanut ports have big valves and have some minor porting work done to them, but let me show you the dyno footage. I'll come back with the complete specs and the results, and I'll show you the results versus the previous 3 tests with different cylinder heads on this motor. Okay, I'm back. Let's review, for anybody that hasn't watched the previous videos, let's review the basic specs of the short block that we're working with here. It's a GM Performance Parts HO short block. It has a truck oil pan on it. It has an LS6 style windage tray. It is a 4-bolt main. It's a standard bore block, so it's a 4.25 bore. The stroke is a 4-inch stroke. It's a GM Performance Parts forged steel crank. Like I said, 4-inch stroke. And then the rods are 6.135. They have 7/16 bolts in them. That's the only upgrade I made on the short block, is I disassembled and put ARP rod bolts in the rods. The pistons are forged pistons by GM Performance Parts, once again, that are 10cc domed. So I've ran this motor with Airflow Research 265s. I've ran it with 781 oval ports, and now I'm testing the peanut ports, the 265 peanut ports. To go backtrack just a little bit, the cam that's installed in this is the GM Performance Parts the ZZ502 cam, and they also use that cam in the 427 ZZ cam, ZZ motor, the 427. The specs on that GM Performance Parts cam is a 224 on the intake and a 234 on the exhaust, duration measured at 50 thousandths. The valve lift is a 527 on the intake and a 0.544 on the exhaust. Those are numbers that are measured with 1.7 rockers. This motor has been ran in all these tests with Scorpion 1.8. So the increased ratio on the rocker arms, you can just figure about 2 degrees extra on the cam and 30 thousandths extra lift. With the increased ratio, there'd be about 30 thousandths more lift on intake and exhaust. I have always ran a Edelbrock RPM air gap on this testing. It had a 1-inch open spacer with a Brawler 770 carburetor. So just reviewing for everybody that's just getting here, the Airflow Research 265s, they produced a maximum horsepower or peak horsepower of a 571 and a 564 foot-pounds of torque. with the airflow research. The combustion chambers on these was 113 cc's. They are fully CNC ported airflow researches. So the compression came in at a 9.3. And the 781s was milled also to a 113 combustion chamber. And the horsepower that they produced was a 515 horsepower and a 546 foot-pounds of torque. Now, in previous videos, I talked about that for the price difference, and for the 781s had factory size valves, the 207 intake and the 172 exhaust. They were Manley valves with a bowl blend on the 781s for head porting. Just a real minor amount of work. Clean up on those heads. I was fairly satisfied with that output of those, with that 781 head, just due to the price, due to the economical cylinder heads. Well, the test that we ran was with the 265s. I'm sorry, the casting number 236 casting number oval port heads. It produced a horsepower of 455 horsepower and 543 foot-pounds of torque. Now, initially, the peak horsepower is very disappointing. They just got killed by the airflow research, which was over 100 horsepower more, and the 781 somewhere around 50 horsepower more. But what I would like to point out, something I was excited about once that I really started to dig into this and look at what happened, is at 4,000 RPMs, the peanut ports outperformed the 781s and the very expensive 265 airflow research fully CNC ported heads. If you're drag racing, the peanut ports are definitely not for you. But what GM designed these heads for, 1-ton trucks, RVs, you got an Impala or a station wagon with a 308 gear and a stock stall converter, they could be the right cylinder head for you. Below 4,000 RPMs, I think the GM engineers got it right. I think they work well. It's just they don't flow enough air to build top-end horsepower. They're all about torque and lower RPM horsepower and torque. So, in review, what was done to the 236 casting number peanut ports, they had large diameter intake valves. I had, in the good ports, I had 2.19 valves in those. In the bad ports that flow away from the center of the cylinder head, away from this combustion chamber, I had 2.25 intake valves on those. On the exhaust ports, I had 188s, and they were well pocket ported. I will run a clip of that at the end. You can see the heads, the work that was done on the bowl area. I've got a little short video of those with the valves out, but I'm also going to run some upcoming motor dynos that I'm going to be doing. But I appreciate you watching. This is Nick. Thank you. Okay, under the category of upcoming videos, this will be the last test this year for the GM Performance Parts HO crate motor short block. I have a set of absolutely stock, low miles, great condition 781s. I'm not going to touch them with a grinder. I'm not doing any porting work, nothing. And I'm just going to run them on the HO short block with a ZZ cam in it and see what we get. So it's really difficult for me not to clean them up just a little bit, but I'm doing absolutely nothing to them other than just cleaning and checking clearances and stuff like that. But this will be the last test for the GM HO motor this year. Okay, under the category of upcoming projects that I got to bring you, I have already dyno tested this. This is a 406 small block Chevy. with casting number 461 cylinder heads, the double humps as they call them. Hydraulic roller of approximately 235 duration at 50 thousandths. Compression is in the low 10s, but that's a 406 that I'll bring you next week. And then, not ran yet, but it's going to the dyno sometime in the next couple of weeks, is our RV 454. Totally stock bottom end, dish pistons, 1970s RV motor. I have upgraded it with casting number 290 cylinder heads, the 101 cc combustion chambers. The head that was used, oval port, for the LS5 454s, and they put them on 396s and 427s in the late 60s and 1970s. So I've upgraded that motor with a set of smaller combustion cylinder heads. The compression on this is going to get up into the low 9s, and picking it up from a 7.7 to 1 compression ratio. I'm anxious to see what those heads make an improvement on this motor. Last time it was ran with just an intake and rockers from just right out of the RV, it made 370 something with 485 foot-pounds of torque. I think we'll see a pretty good improvement with these heads. So thanks for watching. That's all I got today.